Have you ever wondered, what's the most powerful computer in the world? Well, at the beginning of 2024, Frontier at Oak Ridge National Lab and Aurora at Argonne National Lab claimed the top 2 spots for the world's most powerful supercomputers. And soon, they'll be joined by Lawrence Livermore National Lab's El Capitan. These computers operate at the Exascale, performing incredibly difficult and complex calculations at a level never seen before. They enable unprecedented problem-solving for national security, precision medicine, climate research, and so much more. But what does exascale really mean? It's a small word for an almost unimaginably big number. Exascale computers are capable of a quintillion operations per second. That's 18 zeros worth of mathematical calculations in just one tick of the second hand. If we went back in time a quintillion seconds, that's about 18 billion years before the Big Bang. A quintillion is about the number of neurons in 10 million human brains. And when El Capitan comes online, it's expected to become one of the world's fastest supercomputers, capable of over 2 exaflops. That's 2 quintillion operations per second. The exponential improvements in computing power throughout history have been made possible by packing more and more computing power into smaller and smaller spaces. Not only are we reaching the limits of how small we can get transistors, but moving data around within a computing system this large takes a lot of energy. And how do you keep the computers cool enough? Well, when it comes to chips, El Capitan runs on AMD's MI300A accelerated processing units, which combine CPUs and GPUs into a single package with shared memory. This makes them capable of faster and more energy-efficient calculations. But it's not just the hardware. Making exascale computing a reality has required interdisciplinary innovation to computing architecture, data storage and management, and the kinds of software that can run on these machines. In fact, El Cap is the first supercomputer to run primarily on LLNL developed software, which means this system has built-in familiarity and flexibility for everyone who will work on it. But why do we need computers that can perform operations at this scale? At a national lab like Lawrence Livermore, scientists rely on computer modeling and simulations to solve problems that are way beyond the scope of any human. El Capitan will allow us to perform enormous, highly detailed multiphysics simulations that will be the closest we've ever gotten to simulating what happens in the real world. And it'll be able to do them fast and on a regular basis. Simulations that might take a week to perform on Sierra, Livermore's existing petascale computer, could be completed in just a few hours on El Capitan. El Capitan's primary purpose will be to support America's national security missions, ensuring the safety, security, and effectiveness of the nation's nuclear stockpile. But El Cap and its unclassified companion system Tuolumne will also be used to help us better understand nuclear fusion. What happens when an earthquake hits? How to make better next-generation materials? How drug molecules interact with the body so we can create more effective medications? How we can optimize additive manufacturing, and so much more. Throughout computing history, we've pushed the boundaries of humanity's ability to ask questions of our universe. And exascale computing is the next huge step that will let us ask the questions we've never even thought to ask before.